Hello. I'm going to be demonstrating my Python program, which solves any 8 puzzle. Now, an 8 puzzle is essentially a 3 by 3 tile board with 8 tiles on it. And the ninth spot is just a blank, which is used to move the tiles about one by one. And so, for example, you'd probably get this unscrambled picture of a dog, and you move things around in such a way that you probably want this ear up in this top left corner, and so on. Traditionally, it's called an 8 puzzle because you just use numbers like this, 1 through 8, where the ninth spot is the blank, and the goal is to get the numbers in order, row wise, 1, 2, 3, 4, 5, 6, 7, 8, blank. Um, and so anyway, that's how my program solves it. My program is n capable, which means you can realistically do any number of tiles, such as like a 15 puzzle. However, I kept it simple for this demonstration and just made it an 8 puzzle. So let's start. I have some test cases right here that we'll try, as well as one test case which is impossible to solve, mainly because the 7 and 8 are flipped, and there's no way that we can manage to get the 7 and the 8 to be the other way around. So anyway, let's try it. I put an option for a default puzzle, but I'm just gonna press 2 to enter our own. So I'm gonna enter the first one. Let's do 1, 3, 2, 4, 8, 0, and 7, 5, 6. And then I give the option for a couple different heuristics. If you go with the uniform cost search, this is essentially Dijkstra's algorithm. So that's pretty commonly known that A star is Dijkstra's if you don't give it any heuristic. But the point of A star is to optimize your search algorithm, and so I'm going to use 3. I'm going to use the Manhattan distance. I found that to be the best heuristic in this case, and so I'll just type 3 and press enter, and as you can see, it goes through all the different states. So basically, what's happening is a giant tree is being dynamically constructed, and we're adding nodes to a queue, and then according to A star with the heuristic, we're popping certain ones and pushing new ones onto the queue until we get to this final state where it's solved. I made sure to include the height of the tree, like the depth. It got down to 17, which would be ridiculously hard to calculate by hand. So this AI just takes care of that in approximately half a second. If we did it again with, say, the misplaced tile heuristic, probably take more like a second. It's a little bit longer, but let's try it real quick. 1, 3, 2, 4, 8, 0, 7, 5, 6. And let's do misplaced tile. So you can see it working right there. And okay, it took a little bit longer than I thought. 1.7 seconds. So now let's do an even harder one. I believe this one should take a while, just because of how scrambled it actually is. Misplaced Manhattan. Oh, okay, that was actually really quick. But anyway, you get the idea. Whatever scrambled puzzle you get, you just enter it right here, and it'll give you the optimal steps to get there. And this one, geez, look at that, a fraction of a second. So that was a really easy one. But anyway, that's the puzzle solver. Feel free to use it if you have any use for it. And thanks for watching.